Good morning students. Thank you for the subscribers. You have given me a very good support. Thank you very much. As many of you have messaged me, I am planning to take matriculation syllabus also from next week. 9th and 10th matriculation syllabus I am planning to take. So keep watching, share it with your friends also. Okay, so now we will continue with the class. I am doing class 9 triangles chapter exercise 7.2 I am taking exercise 7.2. First two sums are completed, so I will continue with the third sum. Okay. ABC is an isosceles triangle in which altitudes BE and CF are drawn to equal sides AC and AB respectively. So ABC is an isosceles triangle. Okay, in which altitudes BE. So altitudes are BE and CF are drawn to equal sides AC and AB. So it is understood that from the given question that AB is equal to AC. AB is equal to AC. Okay, respectively. Show that these altitudes are equal. So we are asked to prove that, show that the altitudes are equal. Altitudes is this BE and CF. This is equal. Okay. So, for proving that is, we will take these two triangles. That is triangle AEF and triangle AFC. So, these two triangles we will take. Okay. So, in triangle ABE, and triangle ACF and triangle ACF. So in these two triangles, if we take these two triangles, in these triangles only we are having altitudes. So in these triangles also we have altitudes. So we will be taking these two triangles. So in the question itself, it is given that AB is equal to AC. So this is given in the question. So one side it is given that it is equal, and when you take these two triangles, this angle A, this A is common to both the triangles. So that we will write angle A is equal to angle A. So this is common. Angle A is equal to angle A. So angles are equal. Angle A is equal to angle A. Then since it is given that it is altitude, angle AEB, that is this angle, angle AEB is equal to angle AEB. This one we told. Then angle AFC. Angle AFC. So since it is given that it is altitude, it is 90 degree. So it is 90 degree. So this angle is 90 degree. So we got two angles. That is angle A is equal to angle A, that is common. Then angle AEB is equal to angle AFC, that is equal to 90 degree. Then AB is equal to AC, it is given in the question already. So with two angles one side. So by AA's congruency, both the triangles are congruent. Therefore, triangle ABE is congruent to triangle ACF by AA's congruency. That is two angles and one side. So by AA's congruency, both the triangles are congruent. But our question is, show that these altitudes are equal. So we are asked to show that the altitudes are equal. So these two altitudes are one of the sides of the congruency of the triangles that we have proved. So obviously by CPCT, we can say that BE and CF are equal. That is nothing but the altitudes. So BE is equal to CF. This is by CPCT. So don't forget to write the reason for how you got all these things. That is very important. Okay. So by CPCT, we have proved that both the altitudes are equal. Okay. Next sum is ABC is a triangle in which altitudes BE. ABC is a triangle in which altitudes BE and CF to sides AC and AB are equal. So here it is given BE. It is given that BE is the altitude. BE and CF to the sides AC and AB are equal. Here the altitudes are equal, it is given. Okay, here in the question it is given that the altitudes are equal. Okay, so show that that is the given question. Show that triangle ABE is congruent to triangle ACF. This is the first thing. Then the second one is AB is equal to AC. That is ABC is an isosceles triangle. This is the thing they are asked to prove. So, you take triangle ABE. Since it has to be proved as congruent, you take in triangle ABE, that is the smaller triangle ABE, and triangle ACF. And triangle ACF. In triangle ABE and triangle ACF. In these two triangles, angle A is common. Angle A is equal to angle A. So this is common. Angle A is equal to angle A. This is common. Okay. Then since this is altitude, the angle formed at that point is 90 degree. So angle AEB, angle AEB is equal to angle AFC. AFC. So this is 90 degree. Since it is given as altitude, AEB, angle AEB is equal to angle AFC. So two angles we said. Then in the question it is given that the altitudes, in which the altitudes BE and CF to the sides AC and AB are equal. So that means the altitudes are equal. That is BE is equal to CF. So this is given in the question. BE is equal to CF. Altitudes are equal. So BE is equal to CF. So two angles and one side. So triangle ABE is congruent to triangle ACF by AAS congruency. Two angles and one side. So that is by AAS congruency. ABE is congruent to triangle AC. That is the first thing they asked you to prove. So that we have proved. Then AB is equal to AC. That is ABC is an isosceles triangle. That is the second proof. This is the proof for the first one. And for the second one, since we have proved that ABC, since we have proved that the triangle ABE and triangle ACF are congruent, in that only you are having the sides, that is AB and AC. So, by CPCT, we can say that AB is equal to AC. Since we have proved the congruency of both the triangles, we can say that AB is equal to AC. So, this is by CPCT. By CPCT, AB is equal to AC. Since AB is equal to AC, that is the two sides of a triangle, we can say that ABC is an isosceles triangle. ABC is an isosceles triangle. Isosceles triangle. It is an isosceles triangle. This is the thing they asked you to prove. So we have proved it. Next sum is ABC and DBC are two isosceles triangles on the same base BC. So ABC and DBC are two isosceles triangles on the same base BC. So this is the common base to both the triangles. Show that ABD, that is this full angle, is equal to angle ACD. This is the thing we are asked to prove. So we know that in an isosceles triangle, we will have two equal sides and the angles opposite to the equal sides. The angles opposite to the equal sides will be equal. So, in triangle ABC, angle ABC is equal to angle ABC is equal to angle ACB is equal to ACB. So this is first equation. We will take this as first equation for this triangle. So this is using the property of isosceles triangle, that is for the equal sides the base will be equal. The angles opposite, the angles opposite to the equal sides are equal. So with the help of that property, we can say that angle ABC is equal to angle ACB. Okay, so this is by property of isosceles triangle. So this is by property of isosceles triangle. This is the first proof. Then one more triangle is there, the same thing. In triangle DBC, in triangle DBC, since the same thing, since it is an isosceles triangle, the angles opposite to the equal sides are equal. So angle DBC, angle DBC is equal to angle DCB, is equal to angle DCB. So this one we will take it as second equation. So this is also by property of isosceles triangle. So this is also by property of isosceles triangle. Okay, but in the question they asked us to show that angle ABD, that is this full angle, equal to this angle. That is the thing they asked us to prove. So for proving the given thing, we will add the first equation and second equation. So adding first equation and second equation, that is angle ABC. LHS and RHS we will add, that is angle ABC plus angle DBC, angle DBC. So if you add ABC and DBC, what you will get? You will get angle ABD. You will get the full angle. Angle ABD you will get, that is ABC, this angle, and angle DBC, this angle and this angle. If you are adding, you will get the full angle ABD. Same way on the RHS also, that is angle ACB, angle ACB, this angle plus angle DCB, angle DCB. So DCB is this angle. Okay, so if you add these two angles, you will get angle ACD, angle ACD. So what is the thing they asked us to prove? Angle ABD is equal to angle ACD. So this is the thing they asked us to prove, so that we have proved. Okay, so with this I have completed today's class. 3 sums I have done. This is using isosceles triangle property. So keep practicing. Practice well. Whatever doubts you have, please message me. Okay, thank you.